Okay. Well, hello. Um, there's no one on Zoom. There's three of you here.
Oh my god.
I may stop and answer y'all's questions individually. Um, Although I did tell some people I would post the recording. But if you are watching this, if I answer a question during this video and then you email me with the same question, I'm probably just going to ignore the email. Just letting you know. So I'm going to tell everybody to watch the first minute of this video first. Um, okay. So let's talk about let's start with those of you who are here. I don't know you. Others are kind of regulars, but do you have specific questions or did you need general assistance?
Um, Sort of specific as to like what station, like the station one module could look like. So I'm getting confused on that one,
Okay.
and maybe to go over the constraints to make sure I just like have
Yeah.
everything written
Sure.
down.
Sure. All right. So one problem I'm having today, among many, my car didn't start. That's one. Um, I was making a recording on the drive over here to post, an audio recording with tips. My phone didn't record, but yeah.
Um, I got mine to synthesize. I just had to instantiate the modules in the top module.
Mm-hmm.
Um, but now, I mean, it came to my attention that the schematic, I'm not getting anything for station one in my
Okay.
schematic, and then it's not implementing, or I guess that's what you call it.
Okay. So I just got the comment from someone that there was no input from station one. I had a similar problem, and the problem had to do with um, one of the following things. So these are some troubleshooting tips that you can check. So first, check that in your top module when you are instantiating something, so let's say you are making station 0, that the variables that you put here, say T1, T2, well, station 0 wouldn't, well, it wouldn't have, well, it depends on what you call them. Whatever you had here, mode, um, R1, clock, whatever you have here, that when you actually have your module station 0, that these line up the same, that you have the T1, T2 mode, because it can compile and run just fine with different names. It just thinks you meant to call it mode in this module and R1 in this module, and it won't work. But so that's one thing to check. Another thing to check is we found that sometimes if you are using an equals in an always block, changing it to a non-blocking assignment can make a difference. So that's another thing to check. Um, what was the other thing that I found that was causing a problem?
In mine, it was having the end and
Oh
beginning.
yeah, well, you can always check the begins and ends, but that usually keeps it from compiling. Um, but there was something else. It'll come to me through the course of this. Um, One thing I do want to mention, especially for those of you who have come to me for help, is that if you have come to me for help, I may have told you something wrong, and you will want to hear this. So I interpreted the directions to say that your display was supposed to show the number of tasks that were completed. Apparently, your display is supposed to show the number of tasks allocated. And so, if you have come to me for help, then I have told you to keep track of the number of tasks completed. That was not what you're supposed to do. Apparently, you're supposed to keep track of the number of tasks allocated. So, if you have come to me for help in your stations, I have told you to have a variable that is standing for the number, whether something completed a task or not. So I think I called mine like X0 or something. and that became 1 if it completed a task and 0 if it did not. You're not going to want to do that in your stations anymore, probably. The easiest way, I think, to do it is in your allocator. And so whenever you allocate something, whenever you say, like, if you have station 0 task equals T2, if you have a line that says something like that, then you are going to want to have, at that time, you're going to want to update your count, and you'll make, say, count equals to 1, as opposed to 0, which it would have been when you started it, and then you're going to accumulate those somewhere else. So just want to make sure that that was real clear. If I've helped you with something and you need me to help you adjust that, then I'm going to be available after this session to help with that. Okay, so now let me talk about a general problem that I've seen with a lot of people. Not so much the people in this room, because most of you I have helped, but a general problem. So if you're watching this and you think you're done, make sure that you are paying attention to this next thing, and that is what allocate means. So allocate means that you are assigning. So you have, in this problem, you have station 0 and station 1, and your allocator receives 2 tasks, task 1 and task 2. Now, the sample code you have is simple, and it just has 1 station. And so what I've seen almost everybody do their first time through is they look and they see, is station 0 ready? Okay, if so, I'll give it task 0. Okay, now let me move to station 1. Is it ready? Okay, if so, I'll give it task 1. But that's not really how it works. Either of these 2 tasks could go to station 0, and either of these 2 tasks could go to station 1. So if your allocator is not doing that, if your allocator is not capable of assigning either task to either station, you need to look at that and make sure that it is. Okay, now let's talk about, so I had specific questions about how the stations work and about constraints. Okay, so let's talk about station, I'll start with station 0. I've seen 2 successful ways to think about the station. And one way is kind of as a finite state machine. And another way is a little bit more like a counter. Oh, that's another problem that I'm seeing a lot of people have, is that you're assuming that because throughout the semester you've used a counter based on a clock, that you need to have a counter based on a clock. You don't need that because, well, based on a clock that runs continuously, because we're not doing anything continuously. It's not like the lab where you, like, we're lighting up the lights all in a row and then you start it over and doing them again and over and doing them again, or that you're displaying on the 7-segment displays one at a time. You don't need to do anything like that. So you don't need to use the system clock unless you're doing the bonus. Okay, so how would station 0 work? Well, keep in mind that there are 2 kinds of tasks. Well, really 3 if you count idle. So I'm going to say that idle corresponds to the binary number 00, and I'll say that a task of type 1 corresponds to 01, and a task of type 2 corresponds to 10. You don't have to do them that way. I'm just going to be using that. And if you have, you're using the finite state machine method, you will be saying that your machine could be in one. I originally said 3 states because I thought you had to keep track of whether or not you completed a task or not. You don't have to keep track of that anymore. So there's really just 2 states. So you have a type 1 task takes 1 clock cycle. And a clock cycle, all a clock cycle is pressing the button. That advances the clock. It's just a button. That's all it is. So 1 clock cycle, and type 2 takes 2 clock cycles. So the different states that the machine could be in are this state where it does not have another clock cycle to wait, or in other words, it's ready, or it has to wait a cycle. So those are the two possible states. And depending on the type of task it receives will tell you what state it's in. This is so much easier now that I don't have to keep track of whether or not it completed a task. Oh, I didn't finish saying what else I've done. I've lost my stylus that goes with this computer. And so I don't want to talk about other things that could go wrong because they will. Okay. So the way I would do this is the way I do most finite state machines, is I would start with one always block, and that always block would change whenever some of my inputs changed. Let's say that my allocator produces something called S0, which tells station 0 what to do, and S1 that tells station 1 what to do. So S0 could be idle type 1 or type 2, and S1 could be idle type 1 or type 2. So my always block, this one might change on S0. It might also change on other things, but I think S0 would probably be it. And then if I could have a case statement, my case could be based on my state. And since I only have two states, that can just be a single variable. And so I could say that my ready state is state 0 and my wait state is state 1. So if I'm in state 0, then I could have another case statement based on S0. And S0 I'm going to define what my next state is going to be. So if I get a type 0, my next state is going to be 0. If I get a type 1, my next state will still be 0 because a type 1 only takes one clock cycle. But if I get a type 2, then my next state is going to be state 1.
So
Yes.
would we need to represent the numbers to the left, to the right of the next state? Would we need to represent those as binary numbers?
I usually do. I think they would work fine as decimal, but I usually do.
I'm talking about
Over,
on the, I guess, our right is to the left of the case, or the next state.
right here. Yeah, I was just changing those, I think. Are you talking about these?
Yes.
Yes. Again, they probably work as decimal, but I would probably do them as binary anyway. So, or you could use a parameter. And then if you are in state 1, then your next state has to be state 0. And the only other thing we need to do here is to report whether or not we're ready or not. And we can do that in these same case statements. So when I have, let me make this a little neater. Let me make a begin. So if I am, actually, no, I don't want to do that. If I start by saying, if I assume that I'm going to be ready, because most of the time I am going to be ready, then I only have to report when I'm not ready. So I'm going to do this. I'm going to say, always at S0 begin R0 equals 1. I'm going to assume that I'm going to be ready and then just report if I'm not. So if I receive a type of 0, then my next state will be 0. If I receive a type 1, my next state will also be state 0. Oh wait, we just had one, we were able to do these with just one binary number because we just had 2 states. So we don't need to do these. These can just be 0 and 1. 0, 0. Sorry, I only just found out about my misunderstanding of how you had to report it, so I'm figuring out some of these things right here. So no, these do not need to be binary. They can just be 0 or 1 for station 0. Okay, and
so even on your right, those have to be in binary, but with the right to the left.
the S0 is 2 binary bits, is 2 bits, but the case for the state is 1. So for station 0, state is 1 bit. And if you receive a type 2, then I'd want to have a begin here, because I would begin, and my next state would be type 1. I need to report that I'm not going to be ready because I'm going to state 1. Then if I'm in state 1, I don't really need to worry about what S0 is. S0 should have been 0, because if I'm in state 1, I reported that I wasn't ready, so I shouldn't have received a task. So the only thing that's going to happen here is I'm going to say that my next state is 0. And that's the only thing that happens there. And end. So that's my always block that determines what my next state is. So up in my, when I'm listing my variables, I need to have next state listed as a reg because I'm assigning it right here. But then I want to have another always block. And this should be always at positive clock edge. And always at this positive clock edge, that's going to be where you make your state equal to your next state. This would also be a good place where if you, to implement your mode, where you could have, you could check your mode, and if mode equals, however you have it set up, then you could make state equal to 0. So if you're in reset mode, you could do that here as well. You could do that in other places as well. So those are the things that you would put in station 0. So questions about station 0 before I explain station 1 and the other way to do the stations?
So for one, we can, I tried to put end after the 1 colon next state.
This should be end case.
Okay.
So I need 2 end cases. I forget to put the end cases. So I started 2 cases. I hate to put my Vivado up here because then I see people, when I look at my YouTube, I see that there are places where it had an inordinate amount of time watched right here, which makes me think, maybe they're freezing the screen and just typing exactly what I have on the screen. Who would do that? No one would do that. No one would do that.
How late are you gonna be in the office?
Till the cows come home. They come home pretty early though, I think. They come home when it's dark. No. I'm tutoring one person at 7:30, but I told her to meet me here, and so I'm not planning. I may go get supper.
So your office is gonna be open like basically. What about tomorrow?
My office will be open. I don't know when I will be around. I'm planning to be around for the rest of the day to help and answer questions, except for that 1 hour when I'm tutoring, and then maybe if I get grumpy and I'll storm off for a little bit and come back and say, all right, I can help y'all now. But tomorrow I have a 7:30 class. I have a 9:30 class that I often don't go to. And I have a 12 o'clock class that I have to go to, and a 3 o'clock class I have to go to. Okay, so I have not changed mine yet from how I had it, where it's collecting the information about whether it completed a task as opposed to allocating a task. But I wanted to explain the question that was asked about the case statements. So just a general overview. This is not right, so don't copy this. If you're thinking about freezing this on the computer and copying it, it's not right. But so the idea was, the general idea works. I apparently did the mode here. I don't think this is the best place to do it, but I did it at the beginning. And then I had a case statement for what state it was in. So then I had my 3 states, but you really only need 2 states. And then, so at the end of those 3 states, you should have an end case. And then for each state, I had a case based on the input it got from the allocator, of the different possibilities from the allocator, and you should have an end case there. Oh, that reminds me of another tip. So I had big tips at the beginning, troubleshooting. Check to make sure that your variables are in the same order when you instantiate your module as to how they are in your module definition. Another one is anytime you have a possibility of a don't care, make sure you have a default, because I have found that sometimes that can mess things up if you don't. So here, there is no 4th type of task, and so you want to make sure you put a default in there. So just of some sort. Okay, so did that answer your question as to what?
Yeah,
Okay, so we had our general strategy was we started by saying in our always block, we started by saying it was going to be ready, and then we had a case statement based on the state. For station 0, we said we could get away with just having 2 states. Within the state 0, we had another case statement based on S0, and we had different actions for those different ones. For state 1, all we said that you had to do was your next state had to be state 0. Then you would end that case, and you would end your always block. And then you had another always block that was on the clock edge. So that was station 0. Station 1, on the other hand, you're going to need to have more states if you are doing stations with states. So station 1 has the following properties. Type 1 takes 1 clock cycle. No, type 1 takes 3 clock cycles. And type 2 takes 1 clock cycle. So you're going to have 3 possible states here. So your states are going to be ready, wait 1 clock cycle, wait 2 clock cycles. Those would be your 3 states. So when you do your case statement, based on your state, again, do you want to have your default be, you can do it however you want. So I'll have my default be that R1 is that it is ready. And this should be S1, not S0, because I'm in station 1 now. So I'm saying my default is that it's ready, and if it's not ready, I need to say that it's not ready. So if the type of task I received was idle, then I'm going to have my next state is going to come back to my ready state. So remember, I had ready, wait 1, wait 2. If I had a type 1, then my next state is going to be going to this, I'll call my ready state 0, 0, my wait 1, 0, 1, and my wait 2, 1, 0. If I receive a type 1 task, my next state is going to be to go to this weight 2. And if I receive a type 2 task, then my next state is going to be still my ready state. Oh, but if I'm going to, if I have to go to my weight 2 state, then I'm no longer ready. So I need to have a begin. Next state is state 2. R1 is now 0. And end. And then if I get type 2, my next state is 2B00. Okay, and then end case. And so that is if I am in type, if I'm in my ready state. If I'm in either of my other states, so if I'm in state weight 1, the only thing I can do is go to my ready state. So I will have that my next state, actually I want to have a begin here. Wait, did I make it? Yeah, I already said that it was ready. Okay, so I had my default to be that it was ready. So, oh, and right here, all of these cases, if I'm not putting in a default, you should put in a default. So you need to put in a default. All those cases. So, for state 01, my next state is to go back to my ready state. And then my last possibility is if I am in my weight 2 state, then I'm not going to be ready by next time around. And my next state is going to be 2B01. And I need to report that I am not ready. And then I have not been doing it here, so default. And then end case. And then I would end my always block. And then I would have my other always block to actually change the state on the positive edge of the clock. So that is one way to do the stations, yeah.
So for the last state that you just did, where it was B01, or I guess the first one, what would it, so for B00, that's just idle, so everything stays the same, correct?
No, I should have done.
But not like for that one, but,
So these are my states out here.
yeah.
Those are my states.
Mm-hmm.
And then inside, those are the tasks that I received.
Okay. Making sure.
And it's a little bit different than the way that I had talked to people about it before, because we no longer have to account in the states as to whether or not you've completed a task or not. So it's only in your idle state that you care about what task you received, because in your other states you should not have received any other kind of task. So the other way that you can do your stations is kind of with a counter. So So on this one, if you do it like this, um, you would still receive your task. You would still have a clock. You'd still be reporting whether or not you were ready. You don't know what else you have mode. And when I did it with the counter method, I just had one always block. Because I wasn't changing states, I was doing everything all at once. And so you would have your case statement is just based on the task you receive. And you gonna have a countdown timer as to whether you are ready to whether you're ready or not. So actually what we would have here if your timer has reached 0, then you look at the kind of task that you got.
So, that insert sheet, so just, we just mark our inputs and outputs.
For the input sheet.
Hold on a second. Let me explain what I wrote up here. So this one you'll notice is a lot shorter. So all of you who aren't paying attention, If your timer equals 0, then based on whatever instructions you got, if you received type 0, you could set timer back to 0 and say that you're ready. If you received type 1, timer can still be 0 because you'll be ready. If you received type 2, then your timer would be equal to 1 and you're not ready. If your timer does not equal 0, then you subtract 1 from your timer, because then you'll be ready next time. You can reuse this same code for station 1, just changing things up a bit, because you would have, for station 1, you would have, if you receive type 1, then you would make timer equal to 2. I need to have a begin and end here. I'll come back to that in a second. I don't, for this one, I would need to have begin timer equals timer minus 1, and I would need to report that R0 is now 1 again, because it would be ready. So if I was in station 1, I would say if I received type 1, timer equaled 2. If I received type 2, my timer would still be 0. So that would be the only change I would make there.
Why would the timer equal 0 in the event of a task type 2?
Because this is station 1, and in station 1, if you receive type task 2, that takes 1 clock cycle, and this is saying you're going to be ready. Next clock cycle, you're ready. So you don't, I'm not setting a timer. So, and then also in station 1, I would have else begin timer equals timer minus 1, and if, let me get a new page, else begin timer equals timer minus 1 if timer equals 0, R1 equals 1. Else R1 equals 0. So that would be the counter-based way of doing the stations. Something general.
And that would replace the 3 states that we need for station.
So my code is not showing it, so if anyone who's trying to copy this, because I was reporting the wrong thing, so mine is more complicated because I was keeping track of whether or not it completed a task or not. But yeah, it takes the place of the 3 states. Okay, so about the constraints. So first of all,
So, for my allocated, is this looking right? I don't know because
Not quite. It looks like you might have it a little bit back.
because
If T1 equals 0 and T2 equals 0, there's no reason why you would ever need to have F equals 1 because there's no task to allocate, and so why would you ever not be able to allocate one? F equals 1 means you had an error, you couldn't allocate something.
so this would be 0 as well.
And if they're both 0, then you should send everybody 0.
Okay, I see. I didn't know if I needed to follow it here or for this first one. I probably should delete these, right?
You don't need them.
Don't need them. Would it, did they hurt it?
No, but you need to make all of them zeros.
However you declare it.
Okay, so my first question is, if you look up on the screen, I made a version of this that has the pin numbers on it. Does anybody want this? And if so, I will print some out in my office. Okay. Oh, if you're watching this online, gosh, you should have come. Okay, so I just had a question about the allocation, and as far as I know, I have only seen people do it wrong or do it the way I do it, which either means maybe I helped them do it or they came up with the same idea or they got help from someone who came up with the same idea. I am certain there are other ways to do it and I can think of other ways to do it, but I haven't seen any of them. And so if you want to check with me and see if your allocator is right, is doing it right, I will be happy to look at it and see. But I so far have not seen a whole lot of different methods of doing it, which makes me think that if you haven't checked with me, you might not be doing it right. You might think you know that you're doing. You might think you know what you're doing, but you might not. I could be wrong on that. Yes.
You might have said this, but for the counter.
Yes. I have not said it.
Okay. So does that can I go on the allocator or?
It does now.
Okay.
I'll talk about that.
You're gonna okay.
Okay, so I had a question about the display and the 7-segment display. So the way I was doing this before was I was not collecting the data that I thought I was collecting. So the data you need to be collecting is how many tasks have been assigned. So in your allocator, you have some method for deciding what you're allocating. So my variables for allocating were S0 and S1, and in my allocator I made S0, or how did I do it? I did do it as a finite state machine, so I did do it as I did calculate what it would be. I did next S0 and next S1, and I did that not less than or equal to. I did that in an always block based on T0 and T1. And then I had another always block where I actually assigned S0 to next S0. So, however you do this, whenever you assign something that's not 0, 0, you would want to increment your total that is assigned. So before I talk about incrementing it, I'm going to tell you how I dealt with this. And I did it in my display module. You don't have to do it in your display module. You could have a separate module for it altogether. You could do it here in the allocator. But at somewhere, you need to have some variable that's going to hold how many tasks have been assigned. So maybe we'll call this num tasks. And I will say this is output reg 3:0 num tasks. Now the reason I'm making it a 4-bit number, I have a big assignment due tonight, so I'm staying here, but I'm going to be working on my assignment. Okay. So if it's a 4-bit number, then it goes from 0, 0, 0 to 1, 1, 1, 1. And then if I add 1 to 1, 1, 1, 1, it goes back to 0, 0, 0, 0. So I don't have to worry about making it a modulo counter. It will be a modulo counter if it's only 4 bits, because each time I'm going to be adding to it, and if I add to it, it will roll over on its own no matter what, because those are binary numbers.
So would the output reg, like 3:0 num test, would that be the same thing as reg 3:0 counter?
Yes. I'm just trying to not have everybody turn in code that has the exact same variables. So,
Just need that.
okay, so then let's say I have, so somewhere in my allocator, I have said that, actually, I think the easiest place to do that is, yes, the easiest place to do this, now that I think about it, is in my second always block, which is always at positive edge clock. Yes, this is definitely the easiest way to do it. Begin. What is not equals in Verilog?
Equal, yeah, exclamation point,
Okay.
equal.
Actually, I think I'll do equals. Okay, so here's my allocator. This is my second always block in my allocator. So I have that if my next S0 is 0, then I have this new variable that I made that is going to be reg task assigned 0, and I have another one that is task assigned 1. That's just keeping track of, did I assign a task to station 0, did I assign a task to station 1. So if my next S0 is 0, then my task assigned is 0. I did not assign a task to station 0. Else, my task assigned 0 is 1. I did assign 1. And the same for next S1. If next S1 is 0, then my task assigned 1 is 0. Else, my task assigned 1 is equal to 1. And then S0 equals next S0 and S1 equals next S1. And then somewhere in all of your code, you're going to be adding these together. And this is where I had my num of tasks. Will equal num of tasks plus task assigned 0 plus task assigned 1. And you just want to do that once on every positive edge of the clock, because you don't want to be adding it every time it says that, yeah, it's going to be doing something. You only want to do it once a clock cycle. And you could do this right here if you wanted to. If you wanted to do this in your allocator, you could do it here in your allocator. Yeah.
Could we take those two and then just put it in our display, like add it in the display?
Uh-huh.
Yeah.
So currently that's how I was doing it, was in my display. I was adding it in my display, but you could add it here in your allocator as well. What did I call it? Num of task? I don't know what I called it. Whatever. It is just add it up and put it right here. And then wherever you do this addition in your display module, that is a long variable name. I had my display module do an always star. I wanted it to always update. This is going to be where you send it your 7-segment display. So this would be where you'd send it your 7-segment display and all your various different codes for what the different numbers are going to look like. And so forth. Okay, so now constraints. I tend to do my vectored signals big endian with like 1 0 or 3 0. My exception to that is my 7-segment display is 0 7, because the way I have these segments learned is as 1, 2, 3, 4, 5, 6, 7, and the decimal point is 8. And so when I'm putting them, saying what my number looks like, if that's 5, this is how I have them numbered in my head. And in order to make that work, I need to have my 7-segment display go from 0 to 7. But I tend to do my others with the highest, most significant bit first. And so on your board, let's say you are assigning these 2 switches for your mode. Most of us are really only using one mode, but the bonus allowed for more than one, so you might have 2 switches. So in your constraints, you would have this switch be mode 1, and you would have this switch be mode 0. And then you'll have 2 more switches that would be for your task. Yes.
One of the modes is supposed to act as like a reset,
Mm-hmm.
and the other one's just telling it to run normal.
Mm-hmm. So you might have this be, I think I called mine task, I don't know if I called them task 0 and task 1 or task 1 and task 2. But let's say I called them task 1 and task 2. This would be task 1, 0 and task 1, 1. And so if you do them, did I do this? Oh, I'm sorry, 1 and 0. And if you do them in that order, then they are lined up in the order that we do binary numbers. So like if I wanted to assign, so I have task 1 here and task 0 here, and then in my code I had T1 as 1:0. That means if I want to assign task 2, which is binary 1, 0, then I would do this switch on and this switch off.
So for the 2 far left, for the nodes, in my code I did like just reset mode, and then if reset is 0, it's normal, and then if reset is 1, it's 1. But like for that, could I still use that and have it work okay?
So you would call this one reset.
So would I have to use both, or would I just use R2, and then if R2 is switch up, it would be reset, and then it's down?
I think I sent you a note about this. I think didn't I tell you that it wasn't, reset was supposed to be a mode? Or wasn't you? Okay, yeah. So reset is supposed to be a mode. And so I would think that you want to make sure that you do have it as a mode. I mean, you can still keep all your same code. I don't know how you want to, what you would actually want to change with that, but it is supposed to go along with the switches that you have that are called mode. I mean, but since the only mode we have, most of us, is reset and normal, it's really the same thing. And then you would just assign the LEDs. Did anyone have a better understanding of the LEDs? Is it just that the LEDs light up according to what switches you have set?
Yeah.
That is it, okay. And then you have your last LED is F. That should light up if you had an error in allocation.
In the instructions, the only LEDs you actually need are F and then for the mode switches. Those are the only requirements. your actual task switches, they're not required.
Well, hold on, let me make sure on that, because I had a reason for putting them in. So I,
You could tell when they were running, made it easier to look at.
maybe.
Yeah, I have LEDs for my switches as well, all of my switches, just for sake of convenience. But
Mhm.
I don't remember being required.
Why did I think that they were?
You could choose for red. Why does that open? Do it for you?
I get exactly what you said, and I already changed, so.
Oh, I know why I did. Because in this picture right here, under normal operation, he had he had this tasks right here with those LEDs. And normal operation mode was the mode that we were said that we had to have. The switches and LEDs. Yep. Yep. So I got my ideas on the LEDs from that picture that I showed you, but here under the basic requirements, it says the only LED you have to display is the flag and it doesn't even say mode. Must have the normal and reset modes. Normal mode accept 2 types of tasks. Accept 2 tasks simultaneously. Serve 2 stations. A flag, whether it was able to assign them all. 7 segment display. Okay, so but I was basing it on this picture right here. So that's why I had them. But apparently you don't have to have them. The only one you have to have is this F.
Does it have to be at the end?
He did say that, yeah.
I got you.
He said the F output is shown in the rightmost LED. Okay, other things that I can go over. He did say that you had to have a test bench to get full credit. I am not prepared to discuss that yet, but if I can get some alone time ever to complete the test bench, then I might be able to do it and also make a little video about it. And so at some point over the next 6 hours or so, I will try to do that. I don't think it'll be hard, but I do need to figure it out. I have not done it myself yet. I don't know if I've covered everything I wanted to cover. If anybody finds my stylus, please let me know. How was the circuits test?
It was easy.
Oh, good.
Not all of it. That's
your
more than
voice.
on the
I
first
watched so
and
many
second.
videos.
I'm sorry.
On the first and second.
They were so useful, so I had to keep watching them. I couldn't set my
Knew
phone
it.
down.